So the first part of this week, we're looking at quadratic functions and all the different things that you can learn about them. So these problems, if you've read through them at all, have 6 parts to them. So obviously that's quite a bit of information. I'm going to break this up into a couple pieces. So right now I'm going to focus on how to show you guys how to find the vertex and the axis of symmetry. And then we'll move on to domain range and increasing and decreasing, all that in the next part. So the first thing we should maybe talk about, this right here is kind of a basic quadratic function. It's in the form ax squared minus bx minus c, where the a, b, and c are constants. So relating that to this over here, we're essentially going to transform this basic quadratic here into this form here. And we do that by doing this process called completing the square. Now, if we can transform this equation into this form, it makes it much easier for us to pull off what the vertex and the axis of symmetry are, because they're just these numbers that are going to be in our new equation. So here's the trick to completing the square. First off, in order for this to work, the constant out in front of x has to be 1. So what we end up having to do is factoring it out. So if you follow along in your book, and let me see, what page is that on? They give some examples of it on how to handle it when you have a constant out in front here in example 3. But to me, it's a little fuzzy on how they start. So let's kind of clarify things. First off, you want to put these first two terms, the terms with the x's, in their own set of parentheses. But again, this term on the inside of the parentheses has to just be x squared. So you're going to factor out, essentially, whatever this constant is, if there is one, in front of x squared. So we're going to pull the negative 2 out. Okay, and now here, I have to ask myself, okay, negative 2 times what will give me 12x? I'm sorry, negative 12x. If you think about it, negative 2 times positive 6 is what would give me negative 12. So I've got x squared plus 6x here. And now I'm going to add something on here, and I'm leaving my negative 16 off to the side. Okay? So when I complete the square, what essentially I'm trying to do is I'm trying to find the number that will allow me to rewrite this in this form, where it's x either plus or minus something squared. And the way we can figure out what this number right here will be is by using a formula that, again, is in your book. But you're going to do 1/2 times whatever this constant is, and then you're going to square that. Okay, so 1/2 of 6 is 3, right? So you're going to do 3 squared, which of course is 9. So what you're essentially doing, you're going to add 9 here, and wherever you add 9, you're going to subtract 9. But here's where it gets a little tricky. If you've got a constant out in front here, you have to take that into account, because we're not just adding 9. We're technically adding 9 times negative 2 if we multiplied all this back out. So in order to balance this equation, in order to make it so we haven't changed anything, we have to add or subtract the opposite of whatever we've done here. So I'm doing a plus 9 here, but what I've actually done is negative 2 times positive 9. I've actually subtracted 18 by putting this 9 in here. So since I've subtracted 18 in this little chunk here, I'm actually going to add 18 out here. I know that can be a little fuzzy. When there isn't a constant out in front, this is super easy breezy. It's just whatever you've added or subtracted here, you do the opposite on the outside. But this little constant, you have to be aware of it. If you factored something out, you have to take that into account in figuring out what you need to add onto the outside. Okay, so now, since we've done this, when you work out something like this, this number, whatever is in here, since that's a positive 3, that actually tells you what this breaks down to as far as into a perfect square trinomial. So this, we still have our, whoops, -2 out front. But this is actually x, and that's a +3, so +3 squared. Right? Okay, so if you multiplied this all back out, if you wrote out the x + 3 times x + 3, you should get this back out. So again, that's the whole point of this. We're trying to rewrite this so that we can condense it down into this form. And now I just need to simplify my stuff on the outside. I've got a -16, +18, so of course that's +2. And now my equation is in the form of this guy up here. Sorry, I was going to draw a big line, but I think that would be a bit messy. So, okay, now that I've got it in this form, I can just essentially plug in values. So again, make note that this is a subtraction sign. Okay, so since that's subtraction, you're essentially going to do the opposite. H is always going to be the opposite of whatever is in here. So if you've got a +3 in here, then H is -3. If you had a -3, then H is +3. I know it's kind of counterintuitive, but that's what this negative sign does. So H for this problem is -3, and then K is the easy one. K is just whatever this number is out here. It's +2, so K is +2. All right, so now we've identified H and K. So my vertex is just the point -3, 2, and my axis of symmetry, which we'll see in a minute because I'll graph this, is just the line. It's a vertical line where x equals, and again, it's where x is h, so where x is -3. Okay, please let me know if you have questions on this.